Hi, this is Laura Chappell, and in the Troubleshooting for Wireshark book, I mentioned Cascade Pilot as a great option when you're working with large trace files. In this video, I want to show you how to use my 12345 workflow to troubleshoot network performance problems. So we'll use this scenario where we have a user here on the left-hand side, and they want to look at the news. So they want to browse to www.cnn.com. So they type that into the browser and they hit enter. There are 5 basic questions that we're going to answer using Pilot. The first thing is, who do they have to ask for this information? Do they have to go to just one server? Do they have to go to a lot of servers? Then we ask, is the path slow? And we're looking at the round trip time between where the client is and each of the servers that it must communicate with. We also want to know if the path is faulty. So are packets being dropped somewhere along the path? If we did make it all the way to the server, then did we get an error message back? And that's where we look for things such as the dreaded 404 response code. Let's say we did get the message all the way to the server, and the server did reply back, and it's not an error, but was it slow? Is the server dog slow? So these are the 5 basic questions we're going to answer, and we'll use Pilot to answer those questions. I will be creating a workflow by building a directory called My Favorite Views, and I'm going to populate that directory with my favorite Cascade Pilot views. I'll put in numbers in front of these so that you can see the order in which I apply these. But each one of these views will answer one of these questions. Once you create a custom directory like this and you place all your views in it, you can then apply the entire directory to a trace file, and I'll show you how that's done. So let's go over to Pilot. I'll be looking at a trace file called tr-cnn.pcapng, and that trace file is available from the Wireshark book website. I want to build my custom workflow. We can see in the Views section in Pilot that we have a line that says Custom. I'm going to right-mouse click on that line and say Create Subfolder. I'm going to name that new folder My Favorite Views. And now I'm ready to populate that folder with each of the views that I want to apply to trace files. I have 5 views I'm going to add to this folder. The first one is the IP Conversations view, and all I'm going to do is just click and drag it into that new folder. We can see it appears in the folder, and it stays in its original location as well. Pilot just makes a copy of that view. Now the next thing I'm going to look at is average, minimum, and maximum round trip time over time. So we're looking at network performance here. So I'm going to go under Performance, and I'll scroll down to TCP. My web browsing traffic goes over TCP. Under TCP, I'm going to expand the section that says round trip time. And in the round trip time section, the very first entry is average, minimum, maximum round trip time over time. I'm just going to click and drag that up to my custom folder. And I'll show you it's in the folder now. The next thing I'm going to look for is TCP errors. So also under TCP, I can see that there's an errors folder. I'm going to expand it and select the TCP errors overview. I'm going to click and drag this up to my folder. And now I have 3 views. Now I'm ready to look and see, did I receive error response codes from the web server? So I collapsed the TCP section, and now I'll expand the web section. There's top status codes. That's what I'm interested in. So I'm going to click and drag top status codes up and pop that into that folder. And the last thing I want to know is the web server dog slow? Below top status codes, we can see a section called Web Server Performance. I'll expand that. And I'm interested in the line where it says Service Response Time by Web Server Host. I'll click and drag this view up. And now I have my 5 views. Now, just to make it easier to show you the order in which I apply these, I'm going to put numbers in front of each of these. Cascade Pilot will automatically order your views in alphanumeric format, but I want to change the format and have them ordered based on the number in which I apply them. So I'm going to right mouse click on the IP Conversations view, and I'm going to rename this view. I'm simply going to put a number 1 in front. Now I do want the average minimum maximum round trip time over time second, so I'll right mouse click and rename this one, putting the number 2 in front. I'm also going to replace these slashes with dashes because Pilot would prefer to see when I'm renaming that I'm renaming with dashes. I'm next interested in the TCP errors overview, so I'll right mouse click and rename this one. Just putting a 3 in front of it. And then I'm interested in the status codes from the server to see if we had anything such as 404 responses. I'll put a number 4 in front of that one. And then I'll finish it off with service response time by the web server host, trying to figure out if that's a dog slow server. And I'll put the number 5 in front of that one and say OK. So now I have all my 5 views sitting underneath my directory called My Favorite Views. Once you organize a workflow like this, all you need to do is select the directory that contains all the views you want to apply, click and drag it to the trace file you're interested in applying them to. I'm going to move my window a little bit to the left here so we can fit all 5 views. There. At the top you can see here are all 5 of my view tabs. And to move from one view to the next view, I just have to click on the tabs. But I'm going to go in order here to analyze what happened when we tried to load the CNN website. Why was it slow? Well, the first thing we see is that we have quite a few hosts we talk to when we go to www.cnn.com. It's not just one host, it's a whole bunch of hosts. I'm going to right mouse click on the background and choose Resolve All so that I can start to see some of the target names instead of just IP addresses. We can now see that a lot of the web names have been resolved for us, and we go to a lot of different hosts when we're just trying to load the CNN.com website. So this can definitely affect performance. Imagine if instead of going and buying a car at a dealer, you had to go out and buy individual car parts from different stores and bring them all back to your home and reassemble them at your home. Let's take a look at the round trip time. Now we're talking about the path round trip time. Now I'm a 35 millisecond person. Anything above 35 milliseconds and I start to sort of feel like things are sluggish. And I can see there are several points in here where communications to the different servers are going above 35 milliseconds. So that's definitely sluggish performance. Now I'm ready to look for any TCP errors. In other words, when I was bringing back a bag of car parts, did anything fall out of one of the bags and require me to go back and get it again? So I'll click on view number 3. Yeah, it looks like we have a point in the trace file where there were some TCP problems. Looking down under the total TCP errors section, I can see that we have 8 lost segments, so it is like we had car parts dropping out of our bags. Retransmissions are the recovery for lost segments, and duplicate acknowledgements are what I call the mother-in-law packets. Duplicate acknowledgements are complaints by a receiving host saying, where is it? 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 So we do have some lost segments here, but we only have 8, and the trace file contains over 4,000 packets, so probably not a huge issue. Most likely the response time issues are because we have to go to so many hosts to get the information, and the round trip times are not very fast. But let's look and see if we received any 404 error messages. I'll click on view number 4 here. Well, we didn't get 404s, but we do have 403s. So it looks like something we asked for from one of those servers generated a response that says, forbidden, I'm not allowed to get something I asked for. This is a point where having Wireshark integration helps a lot, because I can select this line where it says 403 forbidden, right mouse click, and choose to send this to Wireshark. Now this shows there's my GET request, that's what I asked for, and there's the forbidden message. Clicking on the GET request in Wireshark, I can see what I asked for. Well, I asked for this really long line, and I can tell you I didn't type that in. So if we scroll down a little further, we'll be able to see the referrer line. What was it we were loading that made us go ask for this other item? And obviously this file required some other file, and so we asked for it, and unfortunately that was not provided to us. I'll close down this Wireshark window. And let's look at the last thing. We're interested in service response time by the host. Do we have any of those servers that were just dog slow? And yes, we do. It appears that 3 of the servers have a pretty slow response time, 2 specifically. But if you look down at the names down below, these are ad servers. So if we were bringing up that CNN website, the ads that are showing up on that page are going to be just painting onto the page instead of popping on the page. So we would really notice that. I'll click Close All Tabs to close all of these down. And I'm just going to run the same operation on another trace file. This time, let's see what happens when we try to go out to YouTube, and the performance is not great. Here I have another trace file from the Troubleshooting with Wireshark book. This one's called tr-YouTube bad. I'm going to click and drag my favorite views folder right onto the trace file. There are my 5 views. And let's see if we can spot the problem. First thing is, when we go out and we download a video from YouTube, we only go to one host. When we resolve the name, we can see that it's cache.google.com. Well, Google owns YouTube. Okay. The next tab for the round trip time, it's only at 25 milliseconds. That's pretty good. I'm a 35 millisecond person, so I'd be happy with that. Now let's click on TCP Errors Overview, and this is a problem. A Windows 0 condition is when a receiver runs out of buffer space. So the application is not taking data out of the buffer as it's being received. So I'm probably going to YouTube in my browser. My browser is not picking up data out of that buffer fast enough. So my system is turning around and telling the YouTube server, shut up, shut up, shut up, shut up. I have no buffer space. I have no buffer space. So this is likely the cause of the performance issue when I'm trying to watch a video on YouTube. Let's see if we received any error response codes. Nope. In fact, there's only one response because I only asked for one video. Now let's look at how responsive, time-wise, the YouTube server is. Ouch. 276 milliseconds response time. That's dog slow in my happy 35 millisecond world. So if I were going back to the YouTube server over and over again and going from video to video to video, I probably wouldn't be happy with YouTube that day. When I'm done, I'm just going to choose Close All Tabs. So building these views inside of a directory makes it much faster to find problems. You can also build a workflow for VoIP analysis or for wireless analysis or for analysis of any sort of application on your network.